The embryology of the cardiac conduction system, which includes the sinoatrial (SA) node, atrioventricular (AV) node, bundle of His, and the Purkinje fibers, is crucial for establishing the coordinated contractions that allow the heart to pump blood effectively. The conducting system develops in tandem with the heart chamber's formation and the heart's overall maturation. The heart begins as a simple, tubular structure in the early embryo. As it starts to beat around day 22 of gestation, rhythmic contraction originates from the myocardial cells. Initially, the entire heart tube has pacemaker activity, meaning that all the cells can spontaneously generate action potentials, but with time, specific regions become specialized for pacemaking and conduction. Early on, the wave of depolarization moves from the sinus venosus, the inflow part of the heart tube, towards the truncus arteriosus, the outflow part, establishing a primitive pattern of conduction. As the heart tube loops and the atria and ventricles begin to form, pacemaker activity becomes concentrated in the region of the right sinoatrial junction, the junction between the sinus venosus and the right atrium. This area gives rise to the sinoatrial SA node, which will become the heart's primary pacemaker. The SA node forms from specialized myocytes, heart muscle cells, in the wall of the right atrium, specifically in the sinus venosus region. These cells are derived from the cardiogenic mesoderm and retain the ability to spontaneously depolarize, setting the pace for the heart rate. The atrioventricular AV node and the bundle of His develop at the junction between the atria and the ventricles. This area becomes specialized to delay the electrical impulse slightly, ensuring that the atria contract before the ventricles. The AV node develops from a group of cells in the posterior part of the right atrium, near the septum, within the interatrial septum, specifically near the coronary sinus. These cells are also derived from the cardiogenic mesoderm and are influenced by the proximity to the endocardial cushions. The bundle of His forms from cells in the atrioventricular region that extend from the AV node into the interventricular septum. This bundle then splits into the right and left bundle branches, which will carry the electrical impulse down the interventricular septum to the Purkinje fibers. The Purkinje fibers, which are specialized conducting fibers, develop from the ventricular myocardium. These fibers are initially typical myocardial cells that later become specialized for rapid electrical impulse conduction. As the bundle of His divides into the right and left bundle branches, these branches spread into the ventricles, which further branch into the network of Purkinje fibers. This network ensures that the depolarization spreads rapidly and synchronously throughout the ventricles, leading to coordinated contraction. Several signaling pathways and transcription factors, including TBX3 and KX2.5, TBX5, and SHOX2, regulate the development of the cardiac conduction system. These factors are crucial for the proper formation and specialization of the SA node, AV node, and His Purkinje system. TBX3 is particularly important for repressing the development of working myocardium characteristics in the nodal cells, thereby allowing these cells to become specialized for conduction. NKX 2.5 and TBX5 are essential for the early patterning and differentiation of the cardiac conduction system. After birth, the conducting system continues to mature, and the specialization of the SA node, AV node, and Purkinje fibers becomes more pronounced. The autonomic nervous system also starts to regulate the function of the conducting system, influencing heart rate and rhythm. The conductive pathways are further refined, and their functional connections are optimized to meet the physiological demands of the postnatal heart. Abnormal conduction system development can lead to congenital arrhythmias or conduction blocks. For example, improper formation of the AV node or bundle of His can result in heart block, impairing the transmission of electrical impulses from the atria to the ventricles. Congenital heart defects that involve malformations of the heart structure, such as septal defects, can also affect the development and function of the cardiac conduction system, leading to arrhythmias or other electrical conduction problems. The embryology of the cardiac conduction system involves the specialization of myocardial cells in specific regions of the heart to form the SA node, AV node, bundle of His, and Purkinje fibers. This system develops from the cardiogenic mesoderm, guided by various genetic and molecular signals, and is crucial for establishing the heart's rhythmic contractions. Proper formation of the conducting system is essential for coordinated heart function, and disruptions in this process can lead to significant congenital heart diseases or arrhythmias.